Good morning, everybody. My name is Kim Lockhead. I'm VP of Marketing here at Knowi. And thanks, everybody, for being here and taking the time to be with us today. We'll be talking today about how to architect analytics for data transformation. I have with me today Jay Gopalakrishnan and Sachin Samorta, who is Director of Product Management for Couchbase Analytics and Mobile, and Jay is CEO of Knowi. So welcome, guys. Before we get started, I wanted to do a couple of housekeeping items. So first thing is we are recording the session. So you will get it afterwards through email. The second is that you are all on mute, but we do want this to be as interactive as possible. So if you do have a question, don't be shy. There's a Q&A panel. You'll see it on the bar at the bottom. If you click that, you can enter in your questions. So please feel free to ask questions. We'll have time at the end to run through a Q&A. So with that, we're going to dive right in. As soon as there we go. So as I said, our speakers today are Jay Gopalakrishnan, founder and CEO of Knowi, and Sachin Samorta, who is Director of Product Management and for Couchbase Analytics and Mobile. And both Jay and Sachin are experts in the industry. They've been in the analytics business for a long, long time. They'll be talking a little bit about both Knowi and Couchbase Analytics in just a minute. But first, let's start off with some of the challenges. What are the challenges that surround, supporting digital transformation projects from an analytics perspective? So we did do a little bit of homework ahead of our session today, and we spoke to a bunch of folks about data and analytics and, what they are needing from a daily basis in order to support these digital transformation projects. So we asked them, what they saw as their greatest challenges, and we basically have summarized them here for you. But given the fact that I am not the expert, I'm going to pass the baton over to our experts to kind of go into these in more detail, and from their own perspectives, talk about the challenges they're seeing from their customers. So let's start off with you, maybe Sachin. And maybe you can talk about, what are you hearing from your customers and sort of the market in general about these issues?
Absolutely, Kim. So first of all, good morning, everybody, and thank you for joining us today. I'm really excited to be here. Kim, the analytics landscape is evolving, as we all know, and one of the biggest things that we're hearing from our customers is the time to insight for any actionable decisions that need to be made. They want to reduce that time from wherever they are right now in their journey to as little as possible and get it as close to real time as possible. One of the biggest challenges that we're seeing our customers facing is the fact that if you look at the 3 V's of big data, the volume, velocity, and variety of data, that has grown manyfold over the last few years. A lot of people are collecting data that was not being collected before, and now they're trying to get insights from that data. What that is doing is basically extending their current infrastructure to the maximum possible extent, and that's where people are running into scaling issues, which is where the whole NoSQL movement was born. And since then, what has happened is that there's been a shift in the data architecture. So the new concepts that we're seeing is that instead of moving data around from an operational system to an analytical system, if there is a possibility of making sure that that data can be analyzed in the systems in which it is originating as far as possible, that is certainly something that a lot of our customers are resonating with. The other big thing is that a lot of the current infrastructure, the way it has been set up, has been set up with a very brittle ETL pipeline. There are people who are taking data from their operational infrastructure and then transforming it into the way their reports need to be seen. And in that whole transformation process, there is schema that needs to be designed. And then anytime an application changes, the analytics ecosystem is not able to keep track with the way the applications are evolving. So those are the key things that we've been hearing from our customers. Jay, what are your thoughts here?
Thanks, Sachin. Hello, everybody. Good morning. So to piggyback on what you said, Sachin, the volume, velocity, and variety of data has shifted, and you have your fundamental shift in data architectures inside the enterprise, right? So you got your NoSQL databases, SQL ones, API-based data, and what's happening is that the traditional way of analytics is to take this data, put that into a data warehouse, usually a structured data warehouse, and then have data preparation tools on top, data visualization tools on top, just to get that path from insights. And to go back to your point, that agility in your data, that time to insights from that data, that is what businesses are clamoring for, right? And the existing legacy processes to get there tends to be that slows things down. So anytime you need to change this, raw data changes, then you got to change your schema and put that into your data warehouse, and then propagate that all the way to insight. That takes weeks and months. So that old way of doing things it's not sustainable. It's not, and it's also the new reality is quite different, where you want instant insights. So I think so that we're in a very interesting time for those innovations to be happening. That you also combine the AI and the machine learning piece on top, that allows businesses to go from not just time to insights, but also then predict and do prescriptive things on the data very quickly.
Great, thank you, Jay and Sachin. So let's shift a little bit over now to the architectures themselves and talk about what we've done in the past and why we sort of need to start rethinking those analytics architectures to tackle some of the challenges you guys just laid out. So as everybody on the phone knows, historically, the way that analytics architectures have been done is you have a team of people that go and build somewhat complex data extraction processes and then move data to an area where then analytics can happen. And this has manifested itself in a variety of different ways over the years. Data warehouses, data lakes, relational data stores, yeah, you name it, we've tried it. But going forward, given what we just laid out as the challenges and what we see as the future of analytics, those architectures are not really providing the agility that we need going forward. So again, I'm going to pass the baton over to our experts to kind of go into a little bit more detail about why we're seeing this challenge now with these architectures, and get their perspective on it. So Sachin, since you did such a great job last time, I'll pass the baton to you first again.
Thank you, Kim. So again, I think the steps on the left that are shown over here, like defining an original use case in schema, change in the schema, and then new data sources coming in. This is basically your data lifecycle that is being driven by your application lifecycle. So you start, let's say, with an application that is tracking your CRM data, and then you build your ecosystem, if you will, on how you're going to query that data and what sort of reports you want to generate from that. Based off of where you started. And then you have a whole data pipeline that is essentially taking data from your CRM system and then transforming it into the way that you want to consume your reports, and then making that available to a visualization tool like Knowi to create pretty dashboards for all of the execs. And let's say something changed in that schema. If something changed in that schema, that means that your application now is, let's say, on version 2. And then the whole pipeline process, right, from how you're going to so the first thing you need to understand is the impact of the schema change on your pipeline. So my application is ready, but my analytics is broken. I cannot, for example, get the same dashboard that worked in version 1, or maybe in some cases you can. In many cases, I wanted to add this additional field, maybe that I introduced in the new version of the application as a part of my report. And that becomes a process that, again, would take, like, we've talked about the fact that in mostly agile organizations, that's going to take a week. But if you're looking at some of the more traditional enterprises, I've even had customers come back and talk to us about like taking months and quarters to get some of this going. And then again, the enterprise is agile. There are new data sources that are coming in at a very furious pace. And as those data sources come in, the whole notion of the pipeline continues to evolve, and bringing all of this together with a structured schema is becoming more and more difficult. So that's where there have been a bunch of new approaches that have been outlined for data management. And then the whole, the way the analytics ecosystem is evolving, where the notion of a data warehouse, the data lake, the relation data store, or NoSQL data store being used to derive analytics is becoming increasingly more apparent. And one of the key things that has been a challenge for a traditional NoSQL database has been that the query processing on top of a NoSQL database has been requiring specialized skills. Now at Couchbase, we've been very clear about bringing in your SQL skills and reusing them in this new world of JSON and flexible schema, and then leveraging technologies and techniques that you've known over the years in a way that they can be seamlessly extended in this new world of flexible schemas and agile development. So with that, let me just pass this over to Jay and see what you've been seeing on this part of it.
Thanks, Sachin. Yep. So this has been the traditional way of data processing, and we're seeing some interesting use cases where you got NoSQL adoption that's increasing inside the enterprise. So that in many respects gets rid of this whole notion of having to define a schema up front. Right. So then with schemaless data or semi-structured data, then the question becomes, how do you do analytics on top? Because the traditional BI tools and the business, the space in general is catered for structured and prep data. So there's this new generation of tools that allows you to work with this semi-structured, unstructured data, along with your structured data as well. So that's basically the arena that we play in, right? And then once you get to that data to insights, very quickly a whole other set of opportunities pop up that allows you to do higher order things like predictions, prescriptive analytics, and so on and so forth. That we'll take a look at in the demo section later.
Okay, great. Thank you guys. So, we've talked about, that was really helpful to set the stage about now what are the challenges, why the existing approach may not work going forward. So now let's go a little bit deeper as we're heading into the demo portion of the session today, and talk specifically about these technologies. So since we have a tradition going, we'll continue to move along with Sachin. So Sachin, maybe you could tell us a little bit more about Couchbase Analytics and how you're solving this problem and kind of rethinking data architectures.
Sure. So Couchbase Analytics is the newest service in the Couchbase data platform that is a part of our 6.0 release, which was announced a couple of weeks ago, maybe actually a month ago now, and is going to be GA at the end of this month. So a little bit about Couchbase. Couchbase is built on the most powerful NoSQL technology and delivers unparalleled performance at any scale in any cloud. And I'm not going to go deeper into what Couchbase is, but I think the one thing that I'd like to point out is the fact that we're a data platform that started off as a key value store, then built a document store, provided a language which was very close to SQL, which we call Nickel, for essentially retrieving information and interacting with data that existed in Couchbase. Brought a full text service on top of that. And then now our latest addition over there is the analytics service. And the one thing that I always point out is the fact that Couchbase also has a mobile offering where all the goodness of the NoSQL technology is available on a scaled down embedded database that can run on your device as well. So with that background, let me just talk about how a traditional enterprise solution that is got analytics working right now, that I have come to the conclusion after talking to countless customers. So you have a business application that is generating operational data. And I think the graphic under the operational data header over here is essentially to call out the fact that most applications, or majority of the applications, are generating that data as JSON data itself. And then it goes into an operational store where many of the applications have evolved to essentially be able to store data in its natural JSON format as well. But when it comes to analytics, there is a ETL pipeline that is built. And then what that ETL pipeline would do is transform your JSON data, lose all the richness of the JSON data. So for example, if you have arrays sitting inside of your data, or if you have nested objects sitting inside of your data, all of that needs to be flattened. And that's all a part of your ETL process and the schema design. That's a part of this layer. And then what you have at the end of it is, which hopefully you can see in the table structure at the right next to the analytical DB, is a relational schema that goes into your, that is essentially been created for how you're going to be analyzing that data. So that is stored in your analytical database. Could be a data warehouse or whatever form of the analytical database that you're using. And that introduces a batching and latency at that layer itself. And then what happens is, a lot of people then are taking those data in the analytical database, and then they obviously have dashboards, reporting, a whole bunch of visualization tools, analytics tools that they work with. And that's where there is this other level of batching where if the tool is dependent on the analytical database, then the data is batched at the very source itself. So that's always a big complaint from many of the customers, where they're like, we want to reduce that time that it's taking to ETL that data. And then what we want to do is reduce, as a result of that, the time it takes for us to derive insights from that data. And here, if hopefully you were able to catch the animation, from a Couchbase data platform perspective, we're consolidating the operational and the analytics data nodes in one single layer. So what we're doing with the latest release of the Couchbase data platform is introducing a new type of node that is specialized for analytical processing. And the reason why we're introducing a new node is because we don't want the analytical workloads to interfere with your existing operational workloads. So your business application will continue to generate data. The data is in its JSON format, which is the format of choice for most of the business applications that are out there right now. And then you can store that data as JSON itself. And using the Couchbase database change protocol, we are able to then make that data available for analytical processing in a really, really fast time frame. And as a result of that, you're able to get real-time analytics in the visualization tools that you're using within the enterprise. So the key message over there is that we are consolidating the analytical and the operational processing in a single data platform. We're providing workload isolation so that you don't have to worry about your analytical workloads bogging down your operational workloads. I mean, you cannot have an e-commerce site that is running slow because somebody was trying to figure out like how the sales were for the last 3 quarters. And then last but not the least, you're able to query JSON in its natural format without any sort of transformation. So there is no schema because Couchbase is a NoSQL database. There is no schema involved over here. And we give you the tools using a SQL-like language, which we are calling Nickel for analytics, to be able to query this data in its natural state.
Great. Thank you, Sachin. So Jay, I'm going to ask the same of you to kind of give a little overview of Knowi and then talk about how, Knowi is kind of rethinking analytics for modern data.
Sure, Kim. So we call ourselves AI-driven analytics for modern data because we try to put as many buzzwords as possible into the tagline. Basically, what it means is the modern data piece means that we can interface with any NoSQL or SQL database along with your REST APIs. So we treat that as a data source. You can query it in its natural form. So with Couchbase, the natural form is Nickel. So we can either generate Nickel queries or you can write Nickel queries directly into Couchbase to get the data. And then if it's in nested forms or in array form, we keep that data structure intact. So the key there is, you're not having to relationalize the data in rows and columns, which is the traditional approach with BI. And then the analytics piece is this modern business intelligence, so dashboards, charts, being able to embed that, and along with natural language processing, being able to, from a self-service standpoint, write English things and get results back very quickly. And then the last piece there is this AI machine learning piece, which is essentially, when you look at machine learning initiatives, that generally tend to be separate initiatives where you have your data scientists go in and grab the data to create their models. They might go in and write Python scripts, R or Python scripts to create your statistical model based on the data, right? And then the next challenge becomes, how do you integrate that back into the workflow? So with what we provide, we have an ML layer that you can create your models and then apply those models into incoming data, where you can run a nickel query and then apply this ML model on top of it to give you the results you want. And then being able to do dashboards, visualizations, and trigger actions on top of it to close that loop. So you can think of Knowi as an end-to-end analytics platform that sits on top of any type of data, that eliminates your need for ETLing the data or data preparation before you introduce a visualization tool, but it's a combined platform. And the reason we went and we wanted to solve that entire problem set is that right now, the company was founded because of the frustrations we had with existing tools and processes out there, right? So we had 19 different silos in a company we were at before, where you had to go in and do data warehousing and ETL processes to get into a single store to get insights. And the amount of time, money, people, processes spent is just mind-boggling. So it was started with the concept that there's got to be a better way to do that. So and the way we look at it is that it's a problem after data is collected, and all these pieces are interconnected, and a unified solution would help with that data agility in a big way. So this sets the stage up for a demo piece that we've outlined up for you. So before I get into that, maybe I'll say a few things about the Couchbase and Knowi partnership. So we can sit on top of Couchbase. As I mentioned, it's a native layer that you can type in nickel queries and off you get answers very quickly, right? And then you can also combine that with your other sources. So if you have relational data stores along with your NoSQL Couchbase data store, then you can do multi-source joins on the fly as well. Tim, do you want to? Yeah, thank you. So on the demo side, so we have some interesting demo bits we're planning here. So the first is, I'll hand this over to Sachin in a second to provision an analytics node within Couchbase. And the use case there is this connected car concept. So you have devices inside cars sending sensor data, right? That tells you the tire pressure monitor, if the tire pressure monitoring system is on, how fast it was going, what's the engine temperature, and so on and so forth. And the use case we'll be looking at is, from an analytics standpoint, is there are reports of tire pressure monitoring signs going off in cars, and then we'll mimic a scenario where we'll run through some analysis on that data set itself. So, Sachin will be provisioning the clusters, and he'll show you how easy it is to do that within Couchbase. And then from there, I would run with the analytics side of it from that data set, and then also a couple of other use cases around real-time visualizations and ML piece that we have time for as well. So, Sachin, over to you.
All right. I will share my desktop, and hopefully you can see my Couchbase cluster.
Yep, we can see it.
All right. So what you're seeing here is a dashboard of like what I have in Couchbase. So let me just go back, and this is something that I provisioned on Amazon just before we got started with this webinar. So what I have is a Couchbase cluster where I have the Couchbase data platform deployed. I have different services and different nodes over here. And I think one of the first questions I get is like, hey, you already have the analytics service provisioned over here. And this is, I mean, where an ops persona say how easy or hard is it to get a new Couchbase analytics node provision. So one of my design challenges for the team was that can we get this in 5 clicks or less if you already have a Couchbase server that is provisioned. So what I did was I have another node in Amazon that I'm going to be using for this demo, where I have the latest build of the Couchbase data platform provision. You can get this from our website and our downloads page. What I'm going to do is just add this over here to my my existing cluster. So I'd say that I've done this a few times now, and then I can say very safely we can do this in less than 5 clicks. So let me just add the server, and what I'm going to do is go back to a notepad where I have the address of the server copied. So I'm just going to provide the IP address of the server. I'll have the username for the server over here, and then I'm going to use a very secure password, which is actually password itself. And then I'm going to of all the other services over there, I'm just going to choose the analytics service. So again, just if you're keeping track of the clicks, I'd say that the tabs between text boxes don't count. But if you take that out, then I've basically done 2 clicks right now. One is to add the server, which was in the previous screen, and then the analytics node is what I've selected. So now that I've decided what I want to do, I'm actually going to physically add the server to the Couchbase cluster. And when I do that, this has been 3 clicks. So what's now happened is that this machine has been earmarked for the analytics infrastructure within the Couchbase cluster. But what's not happened so far is because I've not pressed this rebalance button on top. And again, if you keeping track of the clicks, I've just done 3 clicks so far. So I just pressed this rebalance button. And what's happening right now is that all of the data that was there in my Couchbase cluster, which was only in a single analytics node, while I'm actually going through describing what's happening over here, is being moved between 2 different nodes. So there we go. If you notice, I think the rebalancing is complete. So you will see that I have 2 analytics service nodes that are provisioned, and the data is split between those 2 nodes. So this is great. Again, I think from an operational perspective, one of the big things that we've done is we have simplified the whole analytics ecosystem for you. What we've done is we've made it really, really easy for you to add analytics capability. And this is great from a scale out or from a demand perspective. And then if you want to like add, remove nodes, it's as simple as a few clicks on our administration console. Well, that is all fine and dandy, but I think the big thing over here is how can you interact with this data? So let me come back over here, and then I'll actually go back in my history. So I'm just going to show you what the JSON document looks like. I'm just going to say, so this is all ad hoc data exploration and analysis. I just gotten a few documents that were stored in here. So what I'm going to do as we're going through this process is move over to my Visual Studio Code editor just to show you what this JSON document looks like. So there is standard key value pair. So for example, I have the engine temperature over here. I have an indicator which says that the tire pressure monitoring system, whether that's on or off. Interestingly, I'm dealing with 4-wheelers. So I have a JSON array in which I'm getting a whole bunch of tire pressure readings. So this is 4 right now. And then I have an indicators object that's got a bunch of key value pairs within it right now. So, and last but not the least, the other thing I'd like to point out is that there's a location of the car that is being sent as well. And that is at providing the latitude and longitude of the car, depending on where it was. This is all great information. I think what we're looking for is let's say that we're getting a few people that are saying that their tire pressure monitoring system went on. So what can we do to essentially explore data over there? So the first thing that I'm going to do is, and again, I'm going to go back to my cheat sheet and see like what is the total number of cars that is having this issue. So let me just copy paste this query, and I'll go into the Couchbase admin console. go to the analytics workbench, and then once I run this query, I can see that there is quite a bit of cars that actually have are reporting this tire pressure monitoring system indicator being on. And the interesting thing over here is that I put in the limit of 1,000 so that my UI doesn't start to explode, but there seems to be a lot of data coming in from there. So if I wanted to do some further analysis on that, let me see if I can find out which model of the car is actually having an issue. And if you're familiar with Couchbase, if you're familiar with NoSQL technology, I think typically with NoSQL technology, the ability to do ad hoc exploration if you're not doing any key value operations is fairly limited. You have to make sure that you have indexes available in advance, know what your access patterns are. But in this case, as you can see, I have absolutely no indexing defined. I have no knowledge of the access patterns over here. And if I was to run this query, I'd see that this issue is coming from different types of cars here as well. I think one thing that I always like to point out is the fact that with Couchbase Analytics, we are essentially bringing in no ETL to no SQL. And the reason I say that, and that's why this example is so accurate over here, is let me just go back to my data model, my JSON data model. If you notice, there is a tire pressure array over here. This has got 4 values in here. So this means that it's coming from a 4-wheeler. Now, if I wanted to find out, like I'm getting this tire pressure indicator reading on, but let me see if the tire pressure actually is low. So here is, I think, and I'm trying to highlight this on the screen. Hopefully you can see this, where what I'm doing is I am essentially performing an operation on that tire pressure array, and I'm checking that all the values in that are above 30. So as somebody who is running the operations, I know that a PSI of 30 or more means that there is nothing wrong with your tire pressure actually. And if the tire pressure monitoring system is on, even then, that means that this might be a false positive, and I definitely want to do some more digging over there. So let me run this query and show you that, okay, so there are a few cars. Again, I'm using that limit of 1,000 to make sure that it's not taking a long time to show up in my UI, and if there's like way too many documents or way too many cars that are reporting this issue, and it doesn't explode my UI over here. So as you will see, I actually used this query to figure out that there's a lot of false positives that are happening in my ecosystem right now, in the current list of cars that I'm tracking. Now, what that tells me is that there is something amiss, and I need to do some more analysis. And I'm going to hand it over to Jay in like just a second to build a pretty picture around this, because a picture would speak 1,000 words. But the one thing to point out over here is that if you're in the business of making cars and you went from a 4-wheeler to, let's say, a 2-wheeler, or maybe like a 6-wheeler or an 8-wheeler, there's any such thing, then the same query that you have would continue to work and would continue to give you false positives. So which means that our claim of not doing ETL on your JSON data, this is one example of why we make that claim. Because if you had to do this with a relational system, you would have to actually flatten that array, convert it into either 4 columns, or if, for example, tomorrow you had a 2-wheeler, then only use 2 columns, and if tomorrow you had like 6 or 8-wheeler cars, then or trucks, then you would have to go back and change your brittle schema, and rather the schema, and then the pipeline would start to become brittle because you wouldn't know what's coming from which card. So again, the ability to interact with JSON in its natural form is one thing that I definitely want to highlight, and is one of the reasons why we make that claim of bringing no ETL to no SQL. So with that, let me actually hand it over to Jay to show us how to make cool visualizations on top of this by using Knowi.
Thank you, Sachin. So while Sachin was provisioning the node, I'm also setting up the same data store, connectivity to that data store from Knowi here. And so now I've got that set up. Now the next thing we have is to just be able to query that bucket, right? So Sachin mentioned that it's a nested, it's got nested objects, nested arrays in it, and we'll start querying this using the query generator. You can also type in the nickel queries in here directly as well. So let's get there's location information in there. So let's get the lat and long from the data, along with engine temperature and a few other attributes, model type, model type and model year. And then we are specifically interested in cars with the with this tire pressure monitoring system on, right? So we want to grab the TPMS, which is a nested attribute, and then we'll do auto sampling of the data to see if it's on or off. And as you can see, as I'm going through this, you got your nickel query that's generated. I'm just going to take the limit off in this case, and just do a quick preview just to see that we have all the data that we're looking for. Model type, model year, yeah, I think it looks good. And also, if I want to add that tire pressure greater than 30, I'm just going to put that in here, modify the query in here to get us that data. So now we've got this data. Now let's do some interesting stuff with it. So this is on the data plumbing or data engineering side of things, right? So connected cars, spelled properly. Mass. So I'm saving this as basically a data set that non-technical users can go and do their own analysis on. So I'm creating a dashboard and grabbing that data in. So just to summarize what I've done so far, so I've connected to the Couchbase database that Sachin set up, ran a nickel query on that, including querying multi-structured data from it without having to flatten it or relationalize the format. And the first thing, and then now it's time for some analysis on the data itself, right? So since we have lat and long, let's look at where these incidents are happening, right? So looks like most of these are concentrated around California, particularly around San Francisco. So that's tidbit one, right? So if you go into San Francisco, it sounds like it's mostly located around the Bay Area. So now let's do a few more analysis pieces on this to get some answers. And I'll use natural language processing in here. The NLP side of it is you can type in English language queries on this data set to get the insights that you're looking for. So then, for example, we've got engine temperature. So let's say, what is the average engine temperature by model type, for example? And you can see that it's around the same. So engine temperature doesn't seem to have any correlation necessarily. 200 is about what you expect. So we're sort of not on the right track there. Let's say we want to look at the count by model type where the tire pressure monitoring systems are on. And here, you do see something interesting where you have, convertibles. If you put this into a chart form, convertibles having the majority of this issue. So that's another set of tidbits that we can use for analysis. And now let's go beyond this and say, what is for convertibles? What is the model year that where we have this issue? And if you put this into these charts, and you can immediately see that it's 2017 convertibles where there is an issue with tire pressure monitoring system that's faulty, right? So what I've just gone through is, connected to Couchbase, ran a nickel query, and then got into the self-service analytics piece where a business user can ask questions naturally to that data to get the insights that they want, and they can publish out the dashboards and visualizations. So to go back on that data agility piece, we've as soon as you have the data, being able to ask questions on it and share insights is where the power of this combined platform comes into play. So that's the connected car demo. Now let's just switch tracks a wee bit to go through some real-time visualization use cases too. So I would this is an example that this is a use case that we're working with the Cincinnati Reds team on. From Knowi's team, if you could pump some data into Couchbase, that'd be great. And then we'll see this stadium filling up. So just to set the use case here, the Cincinnati Reds, they use Couchbase as part of their real-time analytics stack, and they pump in ticket data that's as they scan in, where they can generate insights from people coming into the stadium. So we are sitting on top of Couchbase, and what you're seeing here is a near real-time visualization of how that stadium is filling in. And Arn from our team is pumping some data into Couchbase at the moment. And as you can see, you know, the dots on the stadium are seating arrangements as tickets are being scanned. Obviously sped up than a normal process, but it shows you what the real-time visualization on the data can do. And this should fill up, and then you can basically go in and do other insights from this data too. So on the visualization side, you know, lots of different options. There were 30 some options you can use to slice and dice and visualize the data, and also embed this inside your application, and create data-driven products of it as well. So now to shift gears one more, this concept of AI-driven analytics and combining this machine learning concept on top of the data. So there's a ML area within Knowi where you can basically build your own models, or you can also create your own models and expose it by an API that we can hook into as well. So I'm just going to create a classification model where the use case is, if you have data that's of people that are likely to default or defaulted on their credit card payments, we'll use that as a training data set. So this is one of those ML model where you're using supervised learning approach, using a supervised learning approach where you want to predict on this field here. And here we're taking some historical data, training that data, and then passing it through a model creation process. So it will ask you a bunch of questions. I'm just going to skip these. Do you have any outliers? Do you have any missing values? Do you want to rescale the data as part of the model creation process? If you're familiar with the ML process, then these would probably resonate. And the main step here is what are the features that go into associating that model, right? So what I'm doing here is traditionally, all of this would have to be a separate process outside of the data silos and outside of the analytics tools. So we're bringing all of this in so you can seamlessly do predictions on top of your existing data and existing queries on Couchbase and other sources too. So choose my features, and then I can go in and run this against a number of models, and immediately we can see that the logistic regression is the winner, because from that training data set, we can do a 80% correlation on that data to say 80% probability that you can use this model to predict who's expected to default on their credit card payment. And then once you have this model published, you can run this against any query. So let's say if I have this credit cards data set within Couchbase, and if I do a quick preview on this, so you have a number of attributes without the likelihood of people who are likely to default, but you can apply this model on top that we've just created. And this would not only run the query, but apply this model to give you the predicted whether or not this person's likely to default. So if you want to just focus on folks who are likely to default, that's what I've just done here. And you can also combine this with other data sources too. So if you want to join this with, say, a SQL database where you have the gender defined there, you can also do that here, which I'm just going to do this here while we're here, just to make this a little bit more complex. So to summarize, what I've just done is, we've created an ML model that allows you to predict the likelihood of customers who are likely to default. Also ran a query against Couchbase, combined that to a MySQL query as well to do some lookups. So doing multi-source joins, applying the ML stuff on top, and giving you this virtual data set that spans all of those things that you can do visualizations and analysis on top of that data. So with that, Kim, I'll hand this back to you. That's the demo piece over, and to take Q&A questions.
Great, thanks, Jay. So let me just get the slides going again here. So do you want to just run through the benefits of Couchbase and Knowi again, just now that we've done the demo, just to kind of bring that back to the value prop?
Yeah, happy to. So just to summarize, we're end-to-end analytics platform on top of Couchbase and other sources. So basically, when Sachin provision analytics knows on the fly within a couple of clicks, and we were pointing to that node to run some queries in its native JSON form, and the results of that, we did some analysis, natural language query processing on, and then went in and did a few more advanced examples with machine learning and multi-source joins together. So to tie this back into the data agility piece, is that in a traditional sense, all of these would have to have gone through a ETL process, schema definitions, a data warehousing, a data preparation, data visualization, then a whole set of another initiatives of machine learning, right? So with this, to go back on this unified analytics theme, is that allows the businesses this agility to get to insights and actions and predictions very quickly.
Great. Thanks, Jay. So I appreciate that. And Sachin, thanks for a great demo. So we're going to head into the Q&A portion of the session today. So we have a few questions that have come in from folks on the phone. So we'll start off with a couple of questions from Gary. So the first one from Gary is, I think to you, Sachin, is Couchbase converting NoSQL to a relational database format?
Absolutely not. Again, I think if you're familiar with Couchbase, so we don't enforce any schema. This is not being converted into a relational format for you to be able to run analytics queries on top of it. What we do is we have a log structured merge tree based storage on the analytics side. That is essentially the reason on how we are able to provide querying on top of your JSON data without having to do any sort of flattening.
Okay, great. And the next question, also from Gary, I think is more to you, Jay. So if Knowi is accessing the data in place, does it mean we have to run analytics outside of production hours to avoid production slowdowns?
It's a good question, Gary. So we provide two modes. One is you can do direct, which means it's always going to hit that data store live, which is how I did that Cincinnati Reds use case. And then there's another mode where you can run the query and then run it at specified schedules or at regular intervals, and then have the results of those queries basically stored or cached on our end. And that concept is very powerful because you can also do incremental queries and then have this think of the virtual data set that builds up over time instead of having to hit your raw data sort over and over again. So, and then you can also use that data set to drive other downstream ones, queries, offline queries as well. So it shields your database from these reporting type loads in a big way.
Cool, thanks, Jay. Then a question from Mohammed. What is, and this is again to you, Jay, what's the difference between Nickel and Cloud9 QL?
Sure, I should have mentioned that in the demo actually. So Nickel is a native syntax into querying Couchbase. And the way Knowi does that, we against all our data sources, is we always do things natively onto the underlying source, because you know, if you're using Couchbase, you've done that for a reason. So there's no reason to basically then put another layer on top of it to mask it. So so the underlying queries against Couchbase are always Nickel. Where Cloud9QR comes into play is to do any advanced transformations on top of the data returned from Couchbase or other sources. Now, Couchbase's query syntax is the most powerful query syntax we've seen in the NoSQL world. So you probably don't need Cloud9QR to do your analytics stuff on top. It's more often the case if you're querying a REST API and then you want to do transformations on the fly, right? Change up fields. You want to do group bias or more advanced things like code analysis or predictions and so on. That's where Cloud9QR comes into play. So it's a syntax that we've developed specifically for analytics type use cases to do transformations on the fly.
Okay, great. And then another question from Laurent is, if there's no ODBC drivers, does this mean you have developed with an API?
That's right. So what we do is we go in deep into each of those databases and see what have they exposed that we can talk to it natively. And so we don't use ODBC drivers for the NoSQL databases, and then basically everything's native. So whatever you can type in by Nickel, we want to expose that by the interface.
Okay, and then another question from Mohammed, and this one's probably for you, Sachin, is, do you have two databases, one transactional and the other analytical? Is that a correct understanding?
No, we just have one database. It's just that we have multiple nodes within the single platform, if you will. And those multiple nodes are the ones that are specialized for the kind of processing that you'd like to do. So, for example, if you're looking at an operational query, there are specialized nodes within Couchbase for handling that workload. If you're looking for more analytical queries that are complex, that are over a larger volume of data and have complex joins and aggregations, then we have a query processor and nodes to go with it for that kind of processing. So from a database perspective, it's one single data platform. But from the ability to handle different kind of workloads, we have specialized nodes just for those workloads.
Okay, great. And I think we got one last question, which is on deployment options. Oh, no, I take that back. We have another one that came in. So what would be the impact of performance on Knowi as data volume increases roughly to 5 to 6 million records in a given time? I'm not sure what time that is, but I'm assuming we can scale to big data.
Yeah, so I think there was also a question from Laurent as well, Kim, but let me tackle this question first. And
right.
So the impact of performance in Knowi as the data volume increases. So the query, the results of the query is going to depend on the underlying data store, right? So if you have 5 to 6 million records and we're running a query against it, depending on if you have indexes and so on, we'll be reliant on how quickly the database returns the data. What we can do, to go back on my answer previously, is that you can do those in chunks. So you can do that to say, I want to just get the queries, the results from the last day or last couple of hours, for example. And that's typically going to be a much smaller volume. But then what we can do is take that data and keep appending to this data set we are tracking for you, right? And so there's more advanced ways to basically be able to chunk that up. It's probably, that's a longer conversation, I suppose, for that, if that's what you're looking for. So.
Jay, I think I'd like to jump in over there and just add to the fact that with Knowi and Couchbase, you're getting native query integration. So as I showed you, I think, and this is what Jay showed in his query as well, you were able to essentially push the processing of the JSON data to the Couchbase layer. So as long as your Couchbase nodes are provisioned correctly, I think from a visualization perspective, Knowi, because it is natively integrated with Couchbase, is able to push that processing down to the database layer itself.
Okay. So just to close up on, Mohammed actually had a follow-up question to his original one about the two databases, one transactional, one analytical. So he got your answer, Sachin, but has another question about, so are all the nodes NoSQL databases then?
Absolutely correct.
Right. Okay.
They're
and
all a part of the Couchbase data platform. Yep.
Yep. Sorry. And then Laurent, get to yours. So how are you able to do analytics on metadata when you use database? When you use a database document, or when you're, I'm not sure.
Laurent, is a question around how do you infer what fields are in there when there's no schema to the data? Is that it? Oh wait. Okay.
Yep.
Yes. So it's a good question. So what we do is we start well, with Couchbase, what we do is we pass in Couchbase has this thing called Infer command, and what the Infer does, and correct me if I'm wrong, Sachin, is that it will sample the data to get you the document structure of what the fields you can find are, and then we are piggybacking on that to display what the fields are. So you don't have to, define schemas and things up front. It's based on this sample. And with other NoSQL databases, if they don't have like an infer type of command, we do that sampling and then figure out what the structure of the documents are. And we also have a facility in the data source where you can specify what sort of queries you want to get those get that structure.
Yeah. And Jay, just to add to that, I think you're absolutely correct. So the way we do this is that we have an Infer service that is available. What that would do is that would actually look at the data that is being stored within Couchbase and be able to infer the schema from that. In addition to that, in our query language, which is NICL for analytics, we have the ability for handling situations where in some cases, for example, there's a difference between missing and null. So data might be missing, it may not be null. So we have all of those constructs built as a part of the query language for interacting with that data as well. Thank you.
Okay, great. Well, we are actually at the top of the hour, so I want to thank Sachin and Jay for their time today and all of the great information and all of the fantastic questions that came over on chat. Again, you'll get this recording, a link to this recording in your email no later than tomorrow morning. And then the recording itself will be available up on our YouTube later today. So thanks a lot, everybody, and have a great rest of your day.